Okay. So let's take the region bound by x, which equals y minus y cubed, and the y-axis, and let's revolve it about yep. And 1 is right here, and that's 0 right there. Flat right there. We call this line 1. Because it can come up like this, go down like that, and it's going to come up like this. Go down like that. Okay. Now, on a problem like this, we have x as a function of y. And so since x is a function of y, think about this. Could we try to use a disk method on this one? But if I drew my disks on this one, what would I have to do? I would have to push my disks in the x direction. But meaning the integral would have to be with respect to x. Ooh, I can't get y as a function of x. So I'm kind of stuck. I only got a choice of one method, which is going to be the shell method. Because when I do the shell method about this type of revolution, well, if I go grab a hold of this a line of rotation and expand outwards, it's going to be an integration with respect to y. So this is line 1, okay? So the volume of something like this, and this is rotated around. I'm not going to draw all of it. Let's say we had our disc, our shells. Okay. Okay, so for doing this problem, you have to imagine that, once again, since this is above it, it's going to be subtraction, and this is going to be the contraction of the shells, okay? So if I plug in my boundaries into this, okay, I'm going to get 1 minus 0. That means I'm beginning at here, okay? And this x distance, according to those boundaries, still needs to correspond to x, which equals y minus y cubed, okay? And so for this one, my shells are now contracting inwards around to that point right there. And just like I put up in the previous lecture, you just do subtraction. So this is the radius right here that you're manipulating. So that's your R, and that's your H. Okay. If it was about the line y, which equals 2, what would it be? Your radius would be 2 minus y, and that's what would be manipulated. Okay. So I'm not going to work this one fully out. It's just a bunch of power rules. It's not that bad. Turns into a bunch of fractions, but this is the formulation of that problem. The formulation of the problem is the hardest